Hi friends, this is 13th lecture of Power System series. In my previous videos, I told you the concept of skin depth and skin effect. So in this video, we will take some questions from these topics. So let's take the first question. So first question is, which has more skin effect, aluminium or copper? In my previous video, I told you a very important formula that skin depth delta is equals to under root of 2 by omega sigma mu, where omega is the angular frequency, sigma is the conductivity, and mu is the permeability. Small skin depth means, suppose if this skin depth is small, then it means less penetration of current in conductor, or it means more current flowing near the surface of conductor. It means more is the skin effect. So for a good conductor, we know that conductivity is very high. So we can clearly see from the formula that when conductivity is high, then delta will be very small. So which result in more current near the surface of conductor. That's why skin effect is more in case of conductors. So if conductor is ideal, suppose, okay, so in case of ideal conductor, it has infinite conductivity. So when conductivity is infinite, then delta will be equals to 0, because you can see that delta is equals to is directly proportional to 1 by root sigma. Sigma is the conductivity. So when conductivity is infinite, then delta will be equals to 0. Then it means whole current will flow near the surface of conductor, or we can say that skin effect will be highest in case of ideal conductor. Now come to the question. So we know that conductivity of copper is more than aluminum. So obviously delta will be less for copper because copper has high conductivity. It means skin effect in copper is more than that in aluminum. Now move to the second question. Where skin effect is more? Electrical machines or transmission line? For this, we all know that windings of a machine are made up of copper, while transmission lines are made up of aluminium. As I already told you in my previous question, that skin effect is more in copper than aluminium because copper has more conductivity. So that's why skin effect will be more in case of electrical machines than transmission line. Now take this another question, whether skin effect is present in case of DC or not. So for this, we know that delta is equals to under root of 2 by omega sigma mu. Here omega is the angular frequency, and what is angular frequency? It is equals to 2 pi f. F is the frequency. So we know that for DC, omega or frequency f is equals to 0. It means delta will be, see, if omega is equals to 0, then it means delta will be infinite. So I told you an expression in my previous lecture that current density J is equals to J max E by minus D by delta. So if we put delta is equals to infinite in this expression, then we will get e to the power 0. Okay, and e to the power 0 is equals to 1. So here e to the power minus d by delta will be equals to 1. So we get J is equals to J max, that is equals to constant. Means current density is constant for a conductor carrying DC current. So there will be no skin effect in case of DC. Now take this next question. Explain the relation between skin effect and frequency. Again, we know that delta is equals to under root of 2 by omega sigma mu, and we know that as frequency increase, then skin depth decrease and skin effect increase. Means at higher frequencies, current penetrates up to smaller depth in conductor because skin effect is high, so the current has more tendency to flow near the surface of conductor. See these conductors. Here red portion shows the area over which current flows. So for DC current, this current flows through the entire cross section. As I already told you in my previous question that for DC, current density is constant. It means Current is uniformly distributed over the entire cross section of conductor in case of DC. Now at 50 Hz means frequency f is equal to 50 Hz suppose, then this current flows through this smaller area. You can see that current is flowing up to the depth delta, and this delta is very small. So here we can see that the area over which current flow decreases when frequency increases. Now see, if this frequency is further increased to 1 kilohertz, then we can see that now current flows through very small area, means skin depth further decreases. So from this we can clearly see that skin effect is increasing when we are increasing the frequency. Now take the last question. Why do we not use iron instead of copper to avoid the skin effect? First understand this question. See, we know that more conductivity means more skin effect, and here conductivity of copper is 6 times more than that of iron. So also copper is more expensive than iron. Then why we use copper instead of iron despite of more skin effect in iron? So answer of this question is, we know that delta is equals to under root 2 by omega sigma mu, and we know that sigma is conductivity and mu is permeability. So here for iron, matter of concern is permeability, and iron has very high permeability. Due to high permeability of iron, it has very small skin depth. At powerful frequencies, losses are very large in case of iron, which outweighs the saving by the material cost. That's why we use copper over aluminium, copper or aluminium, and we do not use iron because it has high permeability. And when frequency is high, then the combined effect of frequency and permeability will decrease this skin depth to a very small value. So now here question is, how skin effect or small skin depth result in losses? We will see application of skin effect in next lecture. Okay, so in next lecture we have to see 2 points. First is how skin effect is responsible for losses, and next point is application of skin effect. So we will see these 2 points in my next lecture. I hope you all enjoyed this lecture. Thank you. Jai Shri Ram.